The second topic we need to talk about for this assignment are these things called logarithms. So we've got the definition of a logarithmic function here. It says the logarithmic function with base a is defined by this relationship that log base a of x equals y implies or means the same thing as a to the y equals x. So an important thing to notice here is that a logarithm is just another way to talk about an exponent. Okay, so on this thing, when we see the side that says log base a of x equals y, we're saying what exponent do we need to raise our base a to so that we get x? So a to what exponent equals x? Well, another way we can write that is that a to the y exponent equals x. And so you can go back and forth between these two forms. So I've got the bases in the logarithm form over on the left, the exponential form over on the right. So I've got the bases in blue, right? So we've got a base a on both scenarios here, and our exponent is in green, right? And then x we call the argument when we're talking about a logarithm. And we do have a couple of stipulations on a, the values we can use for a. So we can add just a little bit of information here. We can have a logarithm written like this, but we need our base a to be a positive number. Okay, so it has to be positive. And also, we're not going to let a be equal to 1. Okay. So the first task we have is we want to kind of get in our head what these logarithms are saying. And remember, they're just another way of thinking about exponents. So let's figure out what some logarithm expressions would equal. So what about if we have this one? If we have log base 10 of 1,000, what's that going to equal? Well, this is saying what exponent do we need to raise 10 to so that we get 1,000? Okay, and in this case, that's going to be 3. Okay? Because how can we write it in exponential form? Well, our base 10 raised to the third power, 10 to the third power, 10 cubed is 1,000. So log base 10 of 1,000 is 3. So these parts match. Okay. And then our bases are here, and then the 1,000s, that's what we're trying to get. Okay, let's look at another one. What if we want to know log base 2 of 32? So this one might not be quite so easy to do in your head. What's that going to equal? Well, this one is going to equal 5. I know that because if I take 2 and I raise it to the 5th power, 2 to the 5th power, we get 32. So we're changing from logarithm form to exponential form. Okay, the base stays the same. Got a base of 2 on both of these. Okay, usually it's a little easier to think about in exponential form. We're more familiar with that 2 to the 5th power equals 32. That's easier for us to think about than log base 2 of 32 equals 5. Okay, but the two equations, they mean the same thing. Let's do one more, and this one might be a little bit trickier to think about. What if we have log base 16 of 4? What's that going to give us? So this is asking us what exponent do we have to raise 16 to so that we get 4. Okay, so our number is raising 16 to an exponent and making it smaller. Okay, so maybe that'll give you a little bit of a hint. On this one, this equals 1/2. Okay, so let's see why that's true. Well, let's try it. If we do 16 to the 1/2 power. Okay, you might know how to do that. If not, remember we can change an exponent of 1/2 to square root. All right, so 16 to the 1/2 power, the square root is 16. Well, that's 4. All right, so 16 to the 1/2 power is 4. So log base 16 of 4, that's 1/2. Okay, that's 1/2. So there are a few properties that can make dealing with things with logarithm expressions in them a little easier. So let's look at some properties here. Okay, the first property that makes our life easier sometimes, we can simplify things, is that if we have any logarithm, so we're just going to call it log base a, doesn't matter what a is other than it's positive and it's not equal to 1. So if we have log base a of 1, what's that going to equal? That says what power do we have to raise a to so that we get 1? Well, anything other than 0 that we raise to the 0th power gives us 1. Okay, in exponential form, that says a to the 0th power equals 1. Okay, so if we have any log of 1, we're going to get 0. Property number 2 says if we have log base a of a, okay, so if the base and the argument inside the logarithm match, what are we going to get there? Well, that is 1. Okay, and this one's maybe makes more sense if we write it in the exponential form. This says if we take a and we raise it to the first power, what's that going to be? Well, anything raised to the first power is just itself, right? It's just a. Okay? So anytime we have a logarithm where the base matches the argument, the number on the inside, we get 1. Property number 3 kind of goes along those same lines. It says we have log base a, and this time inside the logarithm we're going to have a to some exponent. Okay, I'm getting a little more complicated now. We got an exponent inside a logarithm. Don't panic. Okay, what's that going to equal? Well, this is going to equal x. Okay, and if we stop and think about what a logarithm means, that makes sense. Okay, we've got log base a, so we're asking what power do we have to raise a to so that we get the thing on the inside, which is a to the x. So what do we have to raise a to get a to the x? That's x. And in the exponential form, this one seems silly almost. It says a to the x equals a to the x. No argument there. One more. We switch the order around, and this one's a little bit harder to write. Okay, it says if we have a, big A, and then the exponent, we have log base a of x. Okay, so log base a of x is in the exponent of a. What do we get there? Well, this one's might be a little trickier to think about, but we get x. And we get x. So log base a of x says what do we have to raise a to get x? Okay, well, we see that if we can, the short version of this, okay, is that anytime we have a log with a base and an exponential with a base and they match, they cancel out and we get whatever's left in the exponent. We get x. Same thing here, it's just in the other order. So our exponential is base a, our logarithm is base a, so these two cancel out and we get x. Okay, so an exponential with a certain base and a logarithm with a certain base are inverse functions. They undo each other. Okay, so logarithms and exponentials are inverses. Okay, so now let's think about what the graphs look like on these. Okay. So let's start with this one. Let's just think about log base 2 of x. What's that going to look like? Okay. Well, we've got a hint since we said exponentials are inverses of logarithms. Okay. Well, if we think about log base 2 of x, okay, we've got one special point that's going to be on the graph, and we can look back up at our properties. Okay. Look at property number 1. It says if we plug in 1 for x, we know what we're going to get. And if we plug in 1 for x, we're going to get 0. So that means the point 1, 0 has to be on our graph. So over here, go 1 unit to the right, 0 units down, get the point 1, 0 on our graph. Okay. And I put that label right in the wrong place. Okay. And in general, the way this thing is going to look, okay, is it's going to be really close to the y-axis, and then when it crosses through a point 1, 0, it's going to get really flat. Okay. And like how the x-axis is a horizontal asymptote for exponentials, here the y-axis is a horizontal asymptote. Okay, so this thing is going to get closer and closer and closer, but it's never going to cross the y-axis. Okay, it's going to get close, but it's never going to cross. Okay, so let's think about a couple of reflections. Okay. What if we changed our function a little bit? What if we did negative log base 2 of x? Okay. So we do negative log base 2 of x. Let me use a different color. Okay. Since I used blue already, we got negative log base 2 of x. What's going to happen? Well, we're flipping our y values, right? And when we would have had a positive y, now we're going to have a negative y. When we would have had a negative y, now we're going to have a positive y. So just like with our other functions, when we throw a negative sign out in front, that's an x-axis reflection. So what's this thing going to look like? It's going to be flipped like this. It's still going to go through our special point. Still going to go through 1, 0. Get something that looks like that by putting a minus sign out front. And what about a y-axis reflection? What if we want to flip it that way? We'll use a special marker here. Okay, so if we do a y-axis reflection, it's going to look like this. Okay, we're going to have log base 2 of negative x. Okay. So if we do that, that's going to flip our x values over. Okay. So instead of having the point 1, 0 on our graph, we're going to have this point negative 1, 0 on our graph. Okay. What's our graph going to look like? It's reflected over the y-axis, so it's going to come in from down here, go through our special point, and then go off that way. Okay. So with these logarithm functions, you can probably see from the graph, focus on the red one, we can't plug in negative values for x. Okay, so our domain starts right after 0 and goes to infinity, but our range is negative infinity to positive infinity. Okay. Let's look at 2 more types of transformations we can do. We've got the reflections. Right, we did x and y axis reflections. What about if we want to do a vertical or horizontal shift? Okay, well, let's look at this one. If we have something like log base 5 of x plus 2, then what are we doing there? What kind of shift are we doing? We've got a plus 2 out here, so this means we're going to shift our graph up 2 units. Okay. And when we do that, if you're trying to match up a graph, we're also shifting our special point, right? Before we had the point 1, 0, but now since we've shifted up 2 units, this graph would have the point 1, 2 on it. Okay. And one other thing to mention here is to keep things from being confusing. I wrote in these parentheses here, okay, to try to help things not be confusing, but a lot of times you won't see those parentheses used. So if you're doing a horizontal translation, sometimes you would see this written as 2 plus log base 5 of x. Okay? And this would still be shifted up 2 units, just the plus 2 is over on the left side instead of the right side. Okay. One more, what about a horizontal shift? If we're doing a horizontal shift, we could have something like this, log base 10, and horizontal shifts are inside the function with the x, right? So we'd have something like this, x minus 3. Okay. So what kind of shift are we doing here? Well, we've got this minus 3, and it's inside the function with the x, so that means it's a horizontal shift. And remember, you have to think about those signs kind of backwards, so minus 3 is going to be to the right 3 units. And to the right 3 units. So most of these problems in this section, you do have some graphs you're having to match up, but most of the problems in this section are going to be like this, where it'll give you something in logarithm form and it says rewrite it in exponential form. Okay, or maybe it will give you something in exponential form and ask you to rewrite it in logarithm form. So most of the problems in this homework assignment are going back and forth between the two forms. There are a few graph problems in there, but most of them are just understanding how to get from logarithm form to exponential form or exponential form to logarithm form.